For our next example, let's look at number 48. And number 48 is dealing with this group right here. 2x plus y equals 4. Negative 4. Negative 2y plus 4z is equal to 0. And 3x minus 2z is equal to negative 11. And so I just wanted to pick an example where maybe not every variable is present in each equation. No problem. So as we go to write that first equation, its x is 2, its y is 1, its z is 0, and its constant's negative 4. And then this second one has no x's, minus 2 y's, 4 z's, and a 0. And the last one has 3 x's, but no y's, and a minus 2 to give us a negative 11. And so there's our augmented matrix. So we're working for that. We want to get that in reduced row echelon form. So the first thing that I'm going to do is take that first row, and I'm going to take half of that first row. So I'm going to take row 1, and divide row 1 by 2. And as I do so, I'm going to get some new numbers right across the top. I'm going to get 1, 1/2, 0, and negative 2. All my other numbers are going to stay the same. And so as I come down here to fill in the other ones, we got 0, negative 2, 4, and 0. 3, 0, negative 2, negative 11. So I'm in a very good position going through. So now what I'd like to do is clear out this 3. So I'm very goal oriented. I want to get a 1 in that first position and zeros underneath it. And so I'm going to take negative 3 times row 1 and add it to row 3 to produce a new row 3 would be my notation. And so my top row is going to stay the same. My middle row is going to stay the same. And my last row will change, and so I'll do that in a different color. I'll do it in green this time, so we'll get that new row 3 in green. And what will it look like? It'll look like, well, negative 3 times 1 is negative 3 plus 3 is 0. Negative 3 times negative 3 times 1/2 is negative 3/2 plus 0 is still negative 3/2. Negative 3 times 0 is 0 plus negative 2 is still negative 2. And negative 3 times negative 2 is positive 6. Minus 11 is negative 5. And so that's where we will be at right now. Just like that. And there's my augmented part. Well, we're doing pretty good, except we don't have a 1 in the middle area. So we're going to quickly take row 2 and divide it by negative 2 so we get that desired 1. So we get 1, 0, 0. 1/2, and then if I keep going down, actually maybe I shouldn't do it that way. I'll go across the top. 1, 1/2, 0, negative 2. Dividing that second row by negative 2. 0 divided by negative 2 is 0. Negative 2 divided by negative 2 is 1. Negative 2 going into 4 is negative 2. And 0 divided by negative 2 is still 0. And so we have that. And then our bottom row, we're just continuing to bring across. Nothing changed there. We only divided that second row by negative 2. Well, the last thing to do is to clear out that last row by taking, well, how am I going to do that? I could do it by, very quickly, by taking negative 3/2 times the current row 2, adding it to row 3 to produce a new row 3. So notice we're manipulating row 3 again. That's fine. Nothing's going to change in that process. You don't have to put yourself under any undue constraints. And so what are we going to do? We're going to take negative 3/2 times 0 and add it to 0. We get a 0. Negative 3/2 times 1. And for the first time, I think I'm realizing I don't need a negative 3/2. I need it to be positive 3/2, because I'm not going to get that to be 0 unless I use positive 3/2. So positive 3 halves times 1 is 1, plus a negative 3 halves is 0. Negative 2 times positive 3 halves, well, that's negative 3, minus 2 is negative 5. And negative 3 halves times, 3 halves times 0 is 0, plus negative 5 is still negative 5. And then technically there's one last step to do to get it into that reduced row form, and that is to take row 3 and divide it by negative 5. When we do that, we get the top row staying the same, the middle row staying the same, and the last row being divided by negative 5. And so we get that. And now we can start to read our answers, right? So we can begin to see what our answers are. So let's see what those are. It's looking like z should be equal to 1. Awesome. X minus 2z, it needs to be equal to 0. So x minus 2 times 1 needs to be equal to 0. So x has got to be equal to, not x. Sorry about that, guys. It's not x, that's y minus 2z. Forgot where I was. And so we're getting y is equal to 2. So as we start to build this answer, we just got a 2 and a 1. And now we need to figure out what x is. Well, we know x plus a half y needs to be equal to negative 2. So that's x plus half of 2 is equal to 2. And so that's x plus 1 is equal to 2. So x would be equal to 1. Oh, no, it wouldn't. Right? I did that in a way wrong. So what I have is x plus 1 half x is equal to, I forgot my negative on there. And so this should be negative, so when I bring it over, it's negative 3. So as I translate it down from here to here, I drop my negative. But it's a negative 3 coming out. Something didn't feel quite right, and we figured it out. So that's how you would work through the whole process. It's very lengthy, right, as we go back and look at our work. But there's something good in that process because it has other applications. And so just be patient with yourself as you work through these.